is 1, are we? When n is 1, it will be 1, 1. Then when n is 2, it will be 1, 2, 1. Then when n is 3, it will be 1, 3, 3, 1. Try and know that. You can see, if I actually join them together, look at this. It is like a pyramid. Pyramid. You see, like this, like this. So this particular drawing that you are seeing is what we know as what? Pascal triangle. How do I get this? How am I bringing it offhand? When we get to a class that will be telling us about binomial theorem, we are going to be saying something about this Pascal triangle. But let's know that. When n, I told you when n is 1, when n is 0, it will be 1. When n is 2, it will be 1, 1. Two things, 1, 2. When n is 1, sorry, it will be two things, 1, 2. When n is 2, it will be 1, 2, 3. When n is 3, it will be 1, 2, 3, 4. When n is 4, it will be 1, 2, 3, 4, 5. It will be, are you getting it? So, now that means when n is nothing, it will be 1. When n is 1, it will be two things. When n is 2, it will be 3 things, 1, 2, 3. When n is 3, it will be 4 things, 1, 2, 3, 1. Are we together? That is that. Now, see, n is what here? 3. That is what is in here. So, whatever, when I expand this, what I'm going to be putting as the coefficient, I'll multiply the coefficient by 1, by 3, 3, and 1. Are we together? It's a very short way. How do we get this? Is an assignment for you as well. Try and tell me how do they get this. We call this particular diagram, or illustration, we call it what? Pascal triangle. Oh, my marker is not my favorite. Pascal triangle. Are we together? Now note. Now, since we have gotten this Pascal triangle, and the essence of this Pascal triangle is that when I try to expand this in a short way, normally I have written it already that you have to expand this in 3 times. I want to expand it not to use 3 times, not to use factorization. So when I do that, I'll tell you how to do that now. When I do that now, I will multiply all whatever I have. It should be 4 factors. 1, 2, 3, 4. Since our n here is 3. So I will multiply whatever I expand from this bracket. I will multiply with the value of 1, 3, 3, 1. According to the Pascal rules. Are we together? Now, the same thing applicable to this thing. We are still 2. I will multiply this, whatever I see, 1, 2, 1. It should be, when I expand this, it should be 3 things that I will be left with. Then I'll multiply with the value of 1, 2, and 1. Are we together? Now, the next thing to do here now, since we have gotten this, and we have known that this is what to use, we are going to use 2 things. When we get here, I'm going to make use of 1, 3, 3, 1. When I get to this n being 2, I will use 1, 2, 1. Now let me note that for n 2, it will be 1, 2, 1. Then for what? For n 3. N 3, it will be 1, 3, 3, 1. Let me clean this. Not to be more bulky and lengthy. Now this will now be what now? This will be the y plus y equals to. Now let's try and expand this. Note, when you are doing that, this you can make it a and b. Match this with this. And let x, which is variable x, let this carry this first power. S will be 3. Then the s should be 0. So we are doing it from ascending order to descending. So s will be the one that is carrying 3. Then ds will be 0. So then you'll be moving. Until the s carry 3. Then s will be what? 0. Hope I'm communicating. You will see what I'm saying now. We have it to be, what are we having? S, match this and this together. That is how we do binomial theorem under Pascal rules. We are still saying something inside this. You can use that to learn binomial theorem. And this will now be what? X raised to the power what? 3. I told you match it. The what? The x raised to the power 0. When s is 3, the s will be 0. That's what I told you that you do. Then what is the sign that is joining them? Plus. You still bring it back until s becomes 0, and the s will be what? 3. That is what I want to do. That is how we solve what? You solve a question without factorizing. A question that you need to factorize and you don't want to factorize, these are the ways you solve. Then you employ the what? The Pascal triangle inside. Now this will now be what? S raised to power what? It will be reducing. Descending order. S raised to power 2 now. Then the x now, the s will be what now? 1. From 0 to turn to 1. Plus, since it is plus right there, s raised to power what? S raised to power 1, the x will be what? 2. Plus what? S raised to power 0, the s will be what? 3. Are we together? You check here and check here. Are they the same thing now? Yeah. S is 3 here. It later turns to s raised to power 0. The s is 0 here. With the power of 0, it later turns to the s equals to what? 3s. Now, the next thing to do, let's try and do this first before coming to this. Plus, what are we having? 2 in the bracket. What are we left with here? We are left with s plus the x in the bracket. What are we having? Square. Are we together? Now, the next thing to do is make it the y. We are still coming to this. It's because of the space. So the y plus y equals to, what are we? We have what here? S cubed. Anything in law of indices, anything raised to power, the s raised to power 0 is what? 1. So s cubed times 1 will give us what? S cubed. Are we good to go? Do I need to write that down? No. Are we? So, what is joining them? Let me write it down. S cubed is s cubed. The s raised to power 0 give us 1. Now, plus, what are we having? S squared, the x. The s raised to power 1 is the x. Plus, s raised to power 1 is x. Anything raised to power 1 is that number, that variable. Now, the x squared plus this x raised to power 0 is what? 1. What is joining them? Times, which is bracket, the s cubed. Plus 2 in the bracket, s plus the x. 2. Hope you are not getting confused. So it's very simple and what? Straightforward.